friend, you are welcome back to my channel, and in today's video lesson we shall be learning about an important topic in physics, which is projectile motion. So without wasting your time guys, we'll be getting started now. Now look at this very diagram of a projectile motion. This is a typical diagram of a projectile motion. Now a body was initially at this point, it was projected with a velocity u, and u in physics stands for what? Initial velocity. So when the body was projected upward at an angle, that is why it's called a projectile motion, okay? The body was projected with an initial velocity at an angle theta, and the body went upward. Then when it gets to the highest point, it starts descending, okay? Then when it hits the plane of projection, the motion is complete. So this is how a typical diagram for a projectile motion look like. Now let's analyze this. The body that was thrown at an initial velocity u, we can resolve the initial velocity, which is u, into two components. The component that is acting in the y direction and the component that is acting in the x direction. So we say the vertical component and the horizontal component. Now if you look at this, the u subscript y is standing for the vertical component of the initial velocity, while the u subscript x is standing for the horizontal component of the initial velocity at the angle theta. Now the body then keeps going upward. Now remember, gravity is acting downward on the body, and the purpose of gravity is trying to, or is tending to push this object back towards the center of the earth, is it not? So the object is being overcome by gravity such that when it goes to this maximum height, it cannot move further in the vertical direction. So at the maximum height, the vertical component of the initial velocity, that is uy at the maximum height, if you check from here to here, it's higher than every other part, at every other point, is it not? At this very point, we have the highest height, is it not? So at the maximum height, okay, at the maximum height, the u y, that is the vertical component of the initial velocity, is 0. The only velocity we have at the maximum height, emphasis on maximum height, the only component of velocity you have is the u subscript s, and that is the horizontal component. I hope that is clarified. Now, gravity has succeeded in overcoming the body such that the body is not being able to move upward again. The body starts what? Descending. If you observe it, it starts coming downward. Is it not? Now, when it gets to this point, it now has what is called v. This v stands for the final velocity. We know that while u stands for initial velocity, v stands for what? Final velocity. And this very final velocity can also be resolved into two components. Just the same way we can resolve the initial velocity, we can also resolve the final velocity. Now observe, when it was coming downward like this, this is the line of, this is the trajectory of its motion. Now, there is a component of this final velocity that is acting in this direction. And we know that this direction is also related to vertical. So we say Vy. While there is a component acting in this direction too, that will be the horizontal component of the final velocity. That will be Vx. I hope that is clear. So let's see what Vy stands for, what Vx stands for, what Uy stands for, and what Ux stands for. Okay? So let's get that. They said the components of U at a time 0, that is before the motion even starts, when the body was still here. And when the body was thrown, it has an initial velocity which is u. There are two components of that initial velocity. You have the ux and the uy. Now, to get the ux, if you resolve this very velocity, considering this angle theta, okay? Considering this angle theta, you put the angle theta here, and then you close this right angle triangle. If you resolve this, us, which is here, will become u cos theta, while uy will become, the one acting in this side, will become u sin theta. I hope that is clear. So if you are given an initial velocity and you are asked to find the vertical component, that is the uy, This is the formula you use. U sin theta. If you were asked to find the horizontal component, it is the US formula you use, which is what? U cos theta. It's that easy. Now, if peradventure after the motion or during the motion at a certain time t, you were not asked to find the final velocity at that time t, what formula will you use to get your final velocity in the horizontal direction and your final velocity in the vertical direction? These are the two formulas. At that time t, the Vx or the horizontal component of the velocity will be u cos theta. Observe something. Initial component of the velocity in the horizontal direction is also u cos theta. So we are saying in essence that ux and vx are going to be the same. That is, throughout the motion, there is no change in the horizontal component velocity. The velocity that is acting in the horizontal component will remain the same. It's only the velocity that is acting in the vertical component that will alter or that will differ during the course of this projectile motion. I hope that is clear. Now, how do you now get the vertical component of the velocity? You use u sin theta minus gt. We know that g is gravity. T is the time that will be given to you. I hope that is clear. Now observe, Vy and Uy are not the same. And that further, emphasizes the statement that it is the vertical component that changes during a projectile motion. Now, so in essence, you can rephrase it and say that Vx and Ux will remain the same. Okay? While Vy will now be equals to Uy, because u sin theta is what we have here, minus Gc. So you can use either this or this to get your final velocity. Now, how do you now get the single value for the final velocity? These are just the two components of the final velocity. They are not the final velocity. They are the two components. So how do you now add them up? You don't add them with plus and minus. This is the formula to now get the final velocity v. To now get the final velocity after you have gotten the components, this is what you do. You say to get v to be equal to square root of vx squared plus vy squared. If I will put it now that way, I will say to get your final velocity, it will be equals to the square root of the horizontal component of the final velocity squared plus the vertical component of the final velocity squared. This is the formula. Okay? So whatever value you get for your vx and your vy, you square them both, add them up, and take the square root. Now, how do you now get angle of the final velocity? Because when you use the word velocity, it shows that it has a magnitude and it should also carry a direction. Is it not? So, in most cases for projectile motion, they don't just expect you to get the magnitude and don't find the angle. They expect you to find both magnitude and direction. So, to get the angle, that is the theta, for which the final velocity will be acting, the formula to use is tan inverse of bracket Vy over Vx. Like we said, Vy is what? The vertical component of the final velocity, while Vx is what? The horizontal component of the final velocity. So when you take the tan inverse of what you get from this, the answer you get will be the angle or the direction in which the final velocity will be acting at. I hope that is clear. Now what else? I said that the path followed by a projectile. Observe something. This projectile starting from here, it courses like this, then it will hit the plane of projection. This very path that is traced out by the projectile is what is called a trajectory. So the path followed by a projectile, in case you're asking an OBJ question, is called a what? A trajectory. Now moving on from there, this trajectory, that is the path that a projectile will follow, is similar to that of a parabola. So they can put it in this form. The trajectory of a projectile is dash. Is it circular? Is it elliptical? Is it parabolic? It depends, but just know it's either parabola, okay, or you say parabolic. It's parabolic, or you say it is a parabola. Parabola, parabolic, they are referring to the same thing. So just know this for OBJ questions. So guys, now we know this at the back of our mind. I will be taking us to something a bit different. We'll be talking about what is called time of flight, maximum height, and horizontal range. So let's have that now. So about now guys, we shall be talking about time of flight, maximum height, and horizontal velocity. So without wasting your time, let's get started. Now looking at this, time of flight, the symbol for it is T in capital letter, okay? Now, what are the formulas you can use to get your time of flight? Now, before we do that, I have to explain what time of flight is. Time of flight is the time taken for a projectile to return back to the plane of projection. Like I said, I'm just paraphrasing. You can get better definitions from your textbooks. Now, it is the time taken. Imagine the body was there initially. So at the time it was projected, and the time it takes to reach this plane of projection, that total time is what is called the time of flight. The time of flight. Okay? Now the first common formula we use to calculate our time of flight is 2u²sin² over g. What does this symbol stand for? U here is the initial velocity of projection. Theta here is the angle at which the body was projected, while g stands for gravity or acceleration due to gravity. There is a value for it. Sometimes it is given, sometimes you take it as what? 10 meters per second squared. Now this is the main formula for calculating time of flight. Sometimes you can give you a tricky case where they'll say the vertical component of the velocity is that, let's say 10 meters per second squared, calculate the time of flight. The vertical component of a velocity is 10 meters per second squared, calculate the time of flight. Now you have the vertical component of the initial velocity. They said it's 10. We know gravity is 10. So we can actually get our time of flight, is it not? So this is the formula you use when you are given just the vertical component of the initial velocity. Now sometimes you can also use t equals 2 times small t. Now this small t, I'll tell you what it means. Now observe this thing. This is the diagram for projectile motion, right? Now there is a time it takes the body to travel from here to the maximum point, or you say the maximum height. That is small t. Now, from the maximum height, there is another time it takes to descend back to the plane of projection. That is also small t. And the value for this small t and this other small t are the same. So if the time it takes to get here is 5 seconds, the time it will take to descend back to this point is also going to be what? 5 seconds. Both are equal. So if I just know this time, let's say they tell me that the time it takes for a body or a projected body to get to the maximum height is 5 seconds. Calculate the time of flight. I will just simply put it here because twice of it will give me my what? Time of flight. Is that easy? So these are the formulas to take note of when you are asked to find the time of flight, capital T. Now moving on from there, when you are asked to find maximum height, before I explain this, let me quickly just tell you what it means here. Now, if you observe, in this vertical direction, there is just a single point, only one specific point at which the body we can say is said to be at the maximum height. At this very point, you can't compare this vertical distance to this very vertical distance. But let's say at this very point, you can't compare this vertical distance to this very specific, just one vertical distance. So we cannot say that the maximum height is the highest distance traveled in the vertical direction for a projected body. So the highest distance a body travels in the vertical direction is what is called the maximum height. Okay? Now it's symbolized by what? Capital H. Okay, let's see what the formulas are. For finding your maximum height, you can make use of any of these two formulas depending on the variables given. Now the important and the common formula here is u²sin²θ over 2g. U stands for initial velocity. Theta here stands for the angle of projection. G here stands for what? Acceleration due to gravity. So this is the first and the most important formula for maximum height. Now another formula you can use if you are given a tricky scenario. Perhaps you are given the vertical component of the initial velocity and you are given acceleration due to gravity. This is the formula that would work. Okay? It is H equals u sub with y squared over 2g. This can also give you what? Your maximum height. Straight to this part, when you're asked to find horizontal range, as the name implies, horizontal range, that is, it's going to be the distance the body travels in the horizontal direction. And not just that, it is the farthest or the maximum distance the body covers in the horizontal direction. So it was projected from here, it went up to the maximum point, then descend back to the plane of projection. So what is that total maximum distance it has succeeded in covering in the horizontal direction? That will be your range. Now there are formulas you can use to get your range depending on the variables given. The first and most common formula is range is equals u²sin²θ over g. Now we analyze, your u is your what? Initial velocity. Theta, like we all know, is the angle or the direction at which the body was projected. Then the gravity, like we know, is usually 10 or let's say 9.8 depending on the one they gave. Now another formula we can use to get horizontal range is ux times capital T. Ux is the horizontal component of the initial velocity times time of flight. So if you're giving your time of flight straight and you're asked to find range, this is the formula you use. It will make things easy for you. Now, moving on. Another formula you can also use, if perhaps you know the horizontal component of the initial velocity and also the vertical component, you can just simply use this formula. It is 2ux times uy, everything over g. This can also give you your horizontal range, capital R. Now, when you are asked to find maximum range, it is different from when you are asked to find the normal range, because maximum range only occurs at one specific angle. Okay, that's kind of a bit special, and that's where the formula should differ. Okay, now it occurs at an angle of 45 degrees. So whenever a body is projected at an angle of 45 degrees, that body is going to cover its maximum range. But if it's projected at, let's say, any other angle, the body will cover normal range, but that range will usually be less than the maximum range. I hope that is clear. Now, the formula for maximum range, which is R subscript max, is equals u squared over g, because we got that from here actually. If you say theta is 45, 2 times 45 will give you what? 90. And the sine of 90 degrees is exactly 1. So imagine this just disappears. What do you have? U squared over g. So that's how we get the formula for what? R max, or we say maximum range. Now there's a relationship between horizontal range and maximum height. And I did not say maximum range, I said the normal range. Horizontal range, arrow, and maximum height. What is that relationship? I simplify it further like this so that it will look more easy for you to learn. Arrow over h is equals to 4 over tan theta. I repeat, arrow over h is equals 4 over tan theta. So this is where you use it. I'll give you a scenario, a quick one. If in the question, the question was structured like this, they said, a body covers twice, the range of a body is twice its height. Look at it. They said, let's just say, I recap. The range of a projected body is equals twice its height. So whenever I see range, what should I put there? 2h. So instead of range, I will say 2h over h, because I'm working with the formula, equals 4 over tan theta. And look at it, look like. If this was the question, the range of a projected body is twice its height. This is the derivation mathematically, is it not? So whenever I see arrow, I should put it with what? 2h. So putting into this formula, I saw arrow, I'll put 2h over h equals what? 4 over tan theta. Is it not? From here, h will cancel h. What will I have on this side? I will only have 2. It will be equals to what? 4 over tan theta. If I make tan theta subject, if I now make tan theta subject, this is what I will now have. I will now have from 2 equals 4 over tan theta. I will now have tan theta equals 4 over 2. 4 over 2 is what? 2. So I will take the tan inverse of 2. Whatever I get will be the theta. Okay? Don't when I start solving for questions on projectile motion, you understand this better, okay? But for now, take note of all the important formula I have listed for what? Projectile motion. So I hope this quick revision on projectile motion was helpful to you. I hope you now know the key formulas to take note of under projectile motion. See you guys in my next video. Bye for now.